Hey guys, welcome back to the shop. I'm ready to start on my next project here, and this is the long shaft that I've got to machine. I've got some previous videos showing the modifications that I made to mount the steady rest on the milling machine down there to be able to support this long shaft. So we're ready to go ahead and get started on this, and I'll talk you through what we're going to do. So this is the actual shaft right here that we're going to machine. This is 1¼ inch, 1045 steel. This is the chrome plated that you would typically use for like a hydraulic cylinder. And this is what we're going to use. I believe what the customer is doing is he is designing a mud motor, and this is a prototype. So this is a much cheaper, more inexpensive piece of material that you can machine to see if this is going to work. And I believe that if this is something that he's going to end up running or maybe even producing, it will be swapped out to something like a prop shaft material, which would be like an Aquatech 17. But for now, we're going to use this 1045 to get him going and see how his design works. So this is an actual print of the shaft that he has designed here. So I did have it cut to 92 inches, so we got a little bit to trim off the end. Total is going to be 90¼ and each end is machined. You got one side that's pretty much just all threaded here. You've got a turned area here for a bearing, and then on the opposite end you've got a turned down area. It's probably going to be where the prop goes. You got a keyway milled in it, you got a snap ring groove, and then another bearing journal right there. So it's really not it's not a difficult part, a lathe part to machine. The biggest trick is just being able to handle the longer shaft. So long bed lathes ain't no problem. I don't have a long bed lathe, so we're going to go through the spindle to machine it. Let me show you the setup here. This is the steady rest that we're going to use to support the outer end of the shaft coming through the headstock of the Victor. This is something that I showed in a previous video, is machining this, just being supported here on the do-all milling machine. And this is going to work really nice, very nice. We've got a spider. I'll show you that. We got that on the table. Our spider is going to go there. So we'll be using our 6-jaw chuck to support the machined end. You'll have the spider here, and we'll have this indicated, so you'll be running true here, and then the outer end of the shaft is going to be supported here in the steady rest. I machined a couple of bushings that we are going to use. So this is the actual spider that I machined many years ago that goes on the back of the Victor there. And I just made this. This is a split bushing right there that will be fitted inside the spider just like you see. And with it being split, I can draw these bolts in and get it indicated, and then you're not pushing on the actual shaft itself. It's a good way to just protect the shaft and also kind of enlarge that diameter so that you don't have bolts running so far in there. All right, we've also got another bushing right there. This is the one that I made that will be running in the steady rest itself, and that's just to help prevent marring up the shaft. It's not like it really needs it, but it's just something that I like to do to keep from putting the rub marks in the shaft itself. So this is going to slip up on there. Let's see if I can do this one-handed here. All right, so that's going to be up in the the back end of the headstock there, and then we've got our running bushing that's going to be out here. Got a good fit on that, and so this will be running in the steady rest there. I did install brass tipped set screws, and those work really good to keep from marring it up. It doesn't take a lot of pressure to hold this to the shaft, so you don't have to torque down on those very hard. So I believe that's going to be it right there. We've kind of covered it. I need to go ahead and I only added a couple inches there, so I'm going to go ahead and cut this in the bandsaw to length, and then we will start getting this set up in the lathe. Thought I would show you this. This is a great way to visually check a shaft for straightness. Just using my static rollers right here, static balancers. You can put a shaft up in there and spin it, and you can tell whether or not it's bent or not. Now it's not absolutely perfect. I can see a little bit of run out there on that end. It's not bad at all though. But I think this is going to be fine for a prototype shaft, and this material doesn't cost a lot. If it needs to be updated, you can go with, as I said, a piece of like Aquatech or Aquamet 17, and it'll be turned, ground, and polished nice and straight. Getting her cut to size, cutting it 90 3/8, and that'll give us 1/8 of an inch to face off the ends. I've actually got a bad blade now. I need to swap that out with a new one. Back whenever I was cutting the titanium rods, I was using this blade and it actually pulled a couple teeth out of there. So I've got it feeding very slow so it doesn't jump whenever it hits that low spot. But it's still cut, so just got to be real careful with it. Got you on the back of the Victor here. We're going to go ahead and get this installed on the back. We've got 3 set screws. Just push up on there. I've got a modified Allen wrench, just cut it off and made it a stubby so that I can actually reach in here and tighten up the set screws. Alright, just like that. So let's go ahead and get our shaft installed now. We still got to adjust this here, but I've got the height of the mill about where it needs to be. I'm just going to go ahead and get it through there enough where we know we can get it faced off. Just enough to hold it up there right now. We'll go ahead and run these down. So they're sitting right about, they're touching right about in the middle of the pad there. And we'll continue to do some fine tuning on the height here as well. Looks like I got it a little bit offset. Needs to go that way. All right, looks like our split bushing's fitting in there good. Getting pretty well centered. Just got to keep fine tuning it to get it in the middle here. Go ahead and snug our set screws there to keep that from rotating inside the bore. Come on, baby. There we go. Doesn't take a lot, just a little bit, just like that. We've got the chuck snugged up, all 3 jaws there. So we'll go ahead and let's just go ahead and run these down till they just touch. All right, that one's touching. Okay. Go ahead and just kind of snug them evenly. Now we'll stick our indicator down. I got a Noga set up on the top here. I'm just going to rotate it down, and that's not good. The bezel on my sterret sometimes try to pop off with my fingers there handling it. Okay. Doesn't need to be, but we'll go ahead and rotate that up some. I'm just going to spin it by hand. Looking at the high, so the high is kind of split between those two there. That's the wrong wrench. And so you're going to work it with these bolts here, getting it centered. I usually try to get it within 1/2000 max run out. So we'll loosen the low and then tighten the highs. Just keep working it. that's the high right now. That one's a little bit high. That's the low, so we might be able to just back that one out and get it very close. So we're within 2 now. 1 thou, that's the high. So 1/2 thousandths right there. That should be running nice and straight. So let's go ahead and get our outboard support, our steady rest, get it centered up. So a good way to kind of get it level is to actually use a level. We've got our little Starrett 4-inch level here, and it's showing that this is high. So we'll just go ahead and come down with the mill table here, just like that. So that's putting us real close to being the shaft itself being level. Okay. So we've got our bushing snug. So what I like to do is just kind of pick up on it. And if you're one way or the other, if you're too high and too low, usually whenever you apply a little bit of upward pressure, if it's pushing to one side or the other, you'll actually see this moving. You'll see it try to pull back to center one way. But I've actually got that. It feels pretty darn good right where it's at. I'm looking down the pads, and it looks like both of our brass pads are riding right in the middle of it. So I think we're good right about there. We'll go ahead and just run it. You know, we start off slow, and then we step up to a higher RPM, monitoring everything and make sure it's going to be good. But this should run nice and good. The other reason why I like these chrome-plated bars for bushings like this is that they're super, you know, you got a hard outside surface there, and it slides very easy, especially when you apply a little bit of whey oil. That's what this is here, is just whey oil. And just keep it lubed every so often. Looks like we've got pretty decent contact right there. So we'll go ahead and we'll close her up. Got to run this one back in. I got to take this thing apart. This top jaw is very stiff in there, like there's trash or chips or something inside of it. So I need to see that. I need to fix that. And then all you got to do really is just come down until it just touches. Let's go ahead and give her a spin. Got her set in 180. Everything's looking good. By the way, I was going to say, I took the knee handle, the crank handle off the knee, just so that couldn't get bumped or moved in any way. And we've got our table locked as well. It shouldn't go anywhere anyway. So that's running 180. Let's go ahead and bump it up to 370. Running nice. So you just come over here every so often with our oiler. Just put a little bit of extra whey oil on it. Should be good to go. Now what I'll do, I'll go ahead and get this side. I want to face it. I'm not going to center drill it yet. We're going to face it. We're going to run this out, the total amount that we need to. And then once we're ready, we're going to be machining. Then I'll center drill it there. The other thing I'll do is go ahead and I'll lock these with these hex nuts there, lock it in. But since we're just doing one quick face op, I'm not going to lock it in. And then we'll re-indicate this once we get it set where we want. All right, so we're just about ready to start making our cuts. We're going to be running a WNMG 431 insert because this is my favorite turning insert, but I'm actually out of it in the CNMG style, which is this style right there. The CNMG, the benefit that you have with this is that it gives you 8 cutting sides, because you can use these what's considered the odd corners for other tools. You know, I use it for chamfering. I've even got a face mill that uses these corners right there. But I've still got a pack of these Trigon, which is WNMG. So it's the ISCAR. It is the TF chip breaker, and the grade is the IC8250. This is always my go-to carbide insert. I need to see about getting me another pack of these things ordered. They were always reasonably priced, usually between $7 and $8 a piece, which isn't bad. By the way, we're running 600 RPM there. No fuss, no problems. Go ahead and pull her out the required length that we need. I'm just going to loosen up the one and see if it stays there. Loosen up our set screws on our running bushing here. Alright, everything's working just the way we want. Just sliding it through. Our split bushing is staying in place. This one's staying in place because I pushed down on it just a little bit. I'm going to back off that. So I just need to get the shaft set on the chuck end where we need to be, and then we'll lock everything back down. I want a total of 10 inches stick out. Our machine journal, our last journal is going to be 9 inches from the end, so that gives us 1 inch here clearance. Should be good there. 10. Go ahead and snug up our running bushing again. Come on. New set screw, new wrench. Alright, I'm going to back off of that just a little bit. Alright, we'll snug this one back down here, but we'll have to go ahead and set the indicator up and re-indicate. Okay, time to go ahead and re-indicate our outer end here. Nice. Stayed within 2 thousandths. Yep. That's within 1 thousandths. So we're good to run right there. I'm going to see if I can tweak that. That's a 1/2 thousandth right there. Go ahead and 2 of these I had snugged down, those 2. So that's nice right there. All right, let's go to our chuck. Make sure that we're running nice and true on our chuck as well. I've got all 3 pinions of the 6-jaw snug. That is something that I discovered after getting and using this chuck, that it does make a difference whenever you equally tighten all 3 pinions. It helps to keep that scroll centered in there and equal pressure on it. I got people that don't believe me, but it's true. All right, so we're ready to go. We can see we're set up there. So I've got less than 1 thousandth run out right there. And that's going to be good enough for what we're doing right there. If you wanted to improve this, if you really needed to have it closer than that, you can use the set true feature on this backing plate behind the chuck here and dial that in. But we're less than 1 thousandth right there. It looks like maybe 8/10, judging it by eye. 600 RPM, test it. That's looking good. Just keep a little oil squirted back there on the running bushing, and we're ready to go. We'll start with a center drill, and then we're going to get this in turn. This is the one that's going to have about a little over 5 inches of thread, and then you've got another journal right there for a bearing. Just keeping the center drill lubed. Looking pretty good. I'm going to first get my total shoulder length set furthest back, which will be 9 inches there. It's looking pretty good, right about there. All right, we're on 9 inches. I'll set a 0 on my indicator. And we'll go ahead and we'll get it turned down to, let's see, we're going to take that to, I believe it's 984. 25 millimeters is what this is going to be here. And then the thread will be 3/4 10. I'll use my mini cool here to keep things nice and cool. I was just checking my finish there. I've made 2 rough passes across there now, and it was a micing nice and straight on the first pass there, so I'm going to do a check on the second one and see where we're at. Yeah, it's looking good. So we're at, where am I at? 5/10 on that mic. Let me see where I'm at on the tenths on this mic right here. We're right on it. It's between 4 and 5/10 there, so we're running nice and straight. So I will, I'm going to leave this a little bit oversized so that I can finish it real nice, and we'll go ahead and get this area turned as well for our thread. That's one more rough pass across there. That's going to leave the bearing journal 20 thousandths oversized, and I'll come back and finish that out later. We'll get the threaded end done, and then we'll finish the bearing journal on size. I'm getting my 0 set for the next shoulder distance there, which is going to be 5 1/8. And a good little thing to practice doing is go ahead and make you a mark on there, because I've shown this kind of stuff before, because I have at times been kind of, just say, sleeping at the wheel and thinking that I'm still going down. I'm looking at this journal thinking that we're still going to here, and I'll bypass that where I need to stop and then mess the shoulder length up. So putting the line on there just kind of adds a visual reference that you know that you're going to be coming up to a stop right there. Put a little witness mark, just like that. And now we're ready to finish turning that down to 3/4. This is the tool we're using for our undercut. It's 1/8 wide, and we're going to take it right about 130 thousandths deep, which would be the double depth of a 10 pitch thread. That's going to provide a nice corner radius. And a thread relief as well, so whenever I'm coming down and I'm threading, I'll have a place that I can stop. This is how all prop shafts are manufactured. I've got a chart that shows all the dimensions for your threads and your undercut, the width, the depth, all that kind of stuff. All right, we'll go ahead and get this journal finished out here. This is going to be our 25 millimeter journal, and inch dimensions, it'll be 0.984 plus 0 minus 1, so we've got a 1 thou tolerance on that. And if you're wondering why I'm doing oil on these little light finish passes like this with this negative rake tool, the oil just seems to help with this gummy material to leave a better finish than the mist coolant. The mist coolant's mainly just to keep everything cool from getting hot, for my use anyway. Going in here for our final measurement to get down to our final size there. I really enjoy using this Brown & Sharp digit mic. It's got the digits right there for you to read. Very super easy, convenient. So I've got about 11 thousandths that I need to come off this. I'm going to dial in 10 thousandths. That way I can finish this with files and emery cloth and make this a nice finish there. All right, we got our finish there. See what it mics out at. We're getting 985 and 4/10. 985 and looks like 5/10 right there. It's between the two lines there. So as I said, we're going to use our mill smooth file to just kind of knock that down, and then we'll use emery to bring it down to our size, so we've got a nice journal there. And he says that this is actually designed to be a slip fit, so it's not a, you don't have an interference where a bearing is going to be pressed on there. It's they want it to where the bearing unit slides on to that journal there. Some of the tools we'll be using, I've got my 3/4 10 go and no-go gauges, and this also gives you your pitch diameter that you should be able to measure it at. So you've got a range there that you want to stay 0.6832. You want to be that or under, but you want to be above 0.677. So you want this to screw on, but you don't want this to screw on. This actually means that it's too small and it's under what the recommended pitch diameter should be. So I've also got my Lufkin pitch mic right here. This is good for 8 to 13 threads, US or V threads. So we'll be using that to measure our pitch diameter. Here's another little handy trick you can do if you don't have the, all the thread mics and the go no-go gauges. If you just want to do it off math, if you want to figure what your depth is, and this is the depth with the compound set at 30 degrees. That's the style that I use, so that whenever I bring this cross slide back and go back in, I go to a 0. I don't have to keep up with how far I went in on the dial every time. It's easier to go back to a 0 mark and then in-feed your compound. That's the way that I like it. So if you want to figure out what your in-feed is for whatever pitch, you go 0.750 divided by your threads per inch. In this case is 10, 75 thousandths. So that's going to be your approximate in-feed that you're going to be cutting that thread. Now this will get you really close, but don't just, if you do this, don't touch off, feed in that amount and think that's it. You still need to check things and make sure that it's going to work, but this will get you really close right here. We're going to go ahead and make our scratch pass here. I'm just going to go down just a little ways and then stop just like that. I do have my indicator set up on the cross slide here as a backup. Let me show you that. We've got our compound set to 0, and I have a mag back indicator there, so I have 2 0 reference points right there. And on your dial, even threads, you can hit any line on that. I can't engage it anywhere I want because 10 is not divisible by 4, which is what this thread pitch is here, but any of those lines right there we can actually engage and line up on our thread. So just use the pitch gauge here to verify, and we are lined up on 10. So we are good to cut. We're going to go ahead and dial in and start making a cut here. I'm just going to use my thread cutting oil to lubricate the tool. I just kind of blow that smoke out of the way at the very end so that I can see the undercut. Getting pretty close there. I'm actually 10 thousandths off my 75 depth. So I'm just going to go ahead and take a measurement there because we know what we want to be at, 683. So that'll kind of give me an idea of how far we're off on the thread. It's real touchy on a thread pitch mic. You got to get right at the dead top end of it. So we're at 710. So we've still got a little ways to go. Getting down to the last, I'd say 5 thousandths, bring it to size. Making some very light passes here. I'm going to do a spring pass. And I'm going to check it with the pitch mic. So we're pretty much there. I'm gonna have to do I'm gonna do a spring pass because I'm micing it at 684. We want 683, and I'll show you. This is our go gauge. All right, it's starting on there, but it's actually, there's friction against it, so it's starting to get tighter. So I can forcefully screw it on there, but I don't want to do that. So what I'm going to do is make a spring pass, and that's something else I get people to ask me that are not aware. What is a spring pass? Well, anytime that you're making cuts across here on the lathe like this, you're applying tool pressure. So that tool is trying to push that material away as it's rotating. A lot of times it lifts up or it pushes away. So if you come back into your last pass on the exact zero, and you make a cut, you're going to be rubbing the material, and usually you're taking a little bit off there as it makes that pass, and that's what's considered a spring pass, just from the material springing or pushed back on the previous pass there. So let's go ahead and do that. You see how little it's taken off? Just a little bit. So let's go ahead and check that. I'm going to make sure that there's no chips on it. So that's feeling good. I think we got it right there. Let me go ahead and give it a check with the pitch mic, and I'll measure it on both ends and make sure that we're cutting straight. You got to have this thing straight up and down there. So we are at, I'm trying not to look at it and just feel the top dead center of it. And we are at 682. All right, so we're saying 1/1000th under. So this is screwing on there. So we should be good to go. I was going to show you, I'm going to take one of these brass nuts. These, I've got several of these. These are leftovers from way back in the day whenever my dad used to machine quite a bit of marine prop shafts. I've got several of these nuts. These were the nuts that would have been used on it was probably 1.25 inches or 1.8 inches, maybe a 1 inch, but a prop shaft would have a 3/4 thread as well, and you would have a couple of these on there. So the perfect fit. So we've done good on our size. We've got it right there where it needs to be. So we know that he can take any standard nut and it screws on there and fit just the way it's supposed to. And I will point out that this is a class 2A finish on the diameter there, on the pitch diameter. Go ahead and break our corners there, make it approximately 40 thousandths. Last phase is to go ahead and file this right here for our journal. So I want to make sure all the oil is off of it. I like using this stuff right here. Just give it a little spray. We'll go ahead and clean the threads off there as well. It evaporates really fast and it'll knock all that oil off there because you don't want the oil in the file. You can blow dry it just a little bit. I'm going to go ahead and double check my sizing and see where I'm at. I believe I had 1/1000ths to come down. Yep, we got just over 1,000. So I've got one of my good files right here, one of the Mill Smooth. This is a Johnson file, by the way. My file brush. We're going to be knocking off the high spots of the tool marks to begin with. See it hitting the files good there. Just keep the file brush clean so you don't, make a bunch of scratches on there with the chips. So we've got 8/10 left to go. I'll go ahead and check it down here as well. Looks like 9/10 and 8/10 is what we got. So I'm just going to continue hitting it with the file just like this. Still got about 6/10 to go, so I'm just going to keep doing that, and I'll bring it down to about 2/10, and then I'll take some fine emery to give it a nice polish, and it should polish out exactly on 984. Got our last couple of tenths to go, so I've just got some of this emery here. Use this for our final polish. I'm going to give it a check before I get too heavy on it. See where we're at. We've got 2/10, and looks like that one right there, I'm right on size, so I need to hit this outer end just a little bit right here. Looks like 1/10 to go. Just on that very tip. I must not have filed it very much out there. As far as the heat, I don't feel any warmth to it, so it shouldn't shrink on us. So there we go. We hit our 984 right there. So we are good to go. 984. 984. It looks like maybe 1/10 under right there. So all I'm going to do now is take some Scotch-Brite. Let me find my Scotch-Brite. I think I walked off with it. Just got a fresh sheet right there. This is the stuff that I buy at the swap meets, usually $1 a piece, and it works good. So I'm just going to soften everything up, make sure there's no burrs left on the threads right there. I've already filed up in here on both ends where the thread starts and stops. I was hoping to get those little tool marks out of there, but they were more than 1,000ths deep. That's how that gummy material works if you can't get enough surface speed on it. All right, well, I'm going to call that side done right there. It looks good, and everything is right on size, so I'm happy with that.